Hi students, problem number 9. Assuming that energy released by the fission of a single uranium nucleus is 200 million electron volt, calculate the number of fissions per second required to produce 1 watt power. So this type of problems are very important for the plus 2 board examination, and it is very simple also. Now what is the given quantity? The power to be produced is 1 watt, that is 1 joule for every 1 second. Now for that, N by T is equal to the number of fissions per second. Now we know that the energy produced in one fission reaction is given as 200 million electron volt. So this is equal to 200 into 10 power 6. 1 million is 10 power 6 electron volt. So I will convert this into joule. So this is 200 into 10 power 6 into 1 electron volt is 1.6 into 10 to the power of minus 19 and joule. So now you can take this is 2 into 10 power 8. Here there is 10 power 2. So 2 into 10 power 8. This is 2 into 10 to the power of 8 into 1.6 into 10 to the power of minus 19 joule. So 1.6 into 2 is what? 3.2 into here minus 19, here plus 8. So if you adjust the powers, it will become 10 power minus 11. Okay, and this is now in joule. Now this power P is equal to number of fissions per second into energy per fission. We want to find what the number of fissions per second. Therefore, N by T is now equal to P divided by E. So this is equal to 1 watt divided by, that is 1 divided by, so this is numerator 1 divided by 3.2 into 10 to the power of minus 11. So what is the reciprocal of 3.2? 1 divided by 3.2 is equal to 0.3125. 10 power minus 11, when it is coming to the numerator, it will become 10 power plus 11. Okay. Therefore, N by T, number of fissions per second, you can adjust this power as what? 3.125 into 10 to the power of 10 fissions per second. So this is the required answer. So it's a very direct only. So one fission gives this much energy, okay, and how much fissions will give this much energy per second? That is 1 watt is the question. I hope you must have understood this well. Fine.